Good morning everyone, welcome to MSc the online classes. In the previous classes we have discussed about the zeros of polynomial, how to verify whether a number or whether a root is the actual zero of a polynomial or not. And in these classes we will discuss about the division of polynomial, as we are already acquainted with how to divide a polynomial with another polynomial in class 8. Similarly, here we also divide some polynomial with another polynomial. So let's start. Suppose we have a question 6 is divided by 3. Okay. So the answer is 3 to the 6. So the remainder is 0. Suppose same 7 is divided by 3. Then what will the remainder? 2, 3 to the 6, 1. So in this case the remainder is 1, and in this case the remainder is 0. So the remainder 0 means the number 6 is completely divided by 3. Okay, but here the remainder 1, it means the number 7 is not completely divided by 3, it is partially divided by 3. Okay, but here the number 6 is completely divided by 3, or we can say 3 divides 6, but here 3 does not divide 7. So here we get a conclusion that if the remainder is 0, it means the number or the dividend, this is known as the dividend. Okay, the dividend is completely divided by the divisor. But if the remainder is not 0, then the dividend is not completely divided by the divisor. So we can write it. What? We can write it. Note, if the remainder is 0, okay, if the remainder is 0, then what will happen? Then the dividend is completely divided by the divisor, Understood? So 7 divided by 3, we get the remainder as 1. So this note is clear. Now we have to think about that the factor of 6 is 1, 2, 3, 6. Okay, these are the factor of 6. Okay, then we have to find out the factor of 7. The factor of 7 is 1, 7. Since it is a prime number, so it has only 2 factors. And 6 is a composite number, so it has 4 factors. Now, let us define one more thing. That is, okay, if the remainder is 0, then we know that the number 6 is completely divided by 3. And see here one thing. 3 is also the factor of 6. Yes or no? 3 is the factor of 6. Okay, so we get that if a number is completely divided by another number 3, or the number 6 is completely divided by 3, then we can say 3 is the factor of 6. Clear? Okay, let us take one more example here. Here, see, 3 doesn't completely divide 7. Why? Because the remainder is not 0 here. जेहेतु रिमाइंडर 0 नहीं, ताले हमें कहि परिबा जे 3 7 को completely divide करूनी. Okay, since the remainder is not 0, so here see the factor of 7 are 1 and 7. But does the factor of 7 contain 3? No, the factor of 7 does not contain 3. So we can say that if the remainder is not 0, then 3 is not the factor of 7. Here we can prove it. Understood? One more example we can take. Suppose 9 divided by 4. So it will be 4 to the 8. Okay, 1. So here the remainder is 1. So we can say that if remainder is not 0, then 4 doesn't completely divide 9. जदि रिमाइंडर 0 हो नहीं ताले हमें कहि परिया कि 4 टा 9 को कंप्लीट डिवाइड करू जे बोले नो डिवाइड करूनी अंडरस्टूड नाउ वी हैव टू फाइंड आउट द फैक्टर ऑफ 9 फैक्टर ऑफ 9 इज 1 3 and 9 since the remainder is not 0 so here also the factor of 9 doesn't contain 4 so we can say that if the remainder is not 0 or 4 doesn't divide 9 completely then 4 is not a factor of 9. Understood? So, one more example, suppose 8 divided by 4. So, we can say 4 to the 8. So, remainder is 0. And the factor of 8 is 1, 2, 4, 8. Here the remainder is 0. It means 4 completely divides 8. But here also see the factor of 8 contains 4. That's why we can say that if the remainder is 0, then 4 is the factor of 8. Understood? So, finally we conclude that if the remainder is 0, then the number 4, that means here 4 is known as the divisor. Okay? Then the divisor completely divides the dividend. Okay? And second thing we got that. And if it completely divides the dividend, then that divisor or 4 is the factor of 8 because the factor of 8 contains 4. So you can say that the divisor is the factor of dividend and that divisor okay is the factor of dividend. Here, so up to this we are clear. Let us do a long division method of a polynomial by another polynomial. Okay, so let us divide. As we have already know how to divide a polynomial with another polynomial. So first write x cube plus x square plus x. It is divided by x. Since it is also a polynomial, why? Because it is contains 3 terms and each term has coefficient, variable and exponent. It is also a polynomial. It is a type of monomial because it contains 1 term. So we have to divide this by this. Since we have to put here, since there is x, so we have to put x square in order to get x cube. So x into x square is x cube. So these two cancelled out. X square comes to here plus x. Then x is multiplied with another x to get x square. Okay. So it will be these two cancelled out. Then x comes to the down. Then x is multiplied with 1 to give x. So finally these two terms will be cancelled out to give 0. See one thing here. Here also the remainder becomes 0. As we have studied or discussed that if the remainder is 0, then this total term, this is known as dividend. Okay, this is known as dividend. और कौन कहा जाए भाज्य को, sorry भाज्य, and this is known as divisor. Okay. So if the remainder becomes 0, then dividend is completely divided by the divisor. Here also the remainder becomes 0, so we can say that the dividend x cube plus x square plus x is completely divided by x. And another thing also we have that if the remainder becomes 0, then x is the factor of x cube plus x square plus x. Okay, these two conditions as we have studied in note 1. So what are that? The condition is that x completely divides this and x is the factor of this. We can say that. So by long division method we can say whether a divisor is completely divides the dividend or whether the remainder becomes 0 by using long division method. But there is some procedure through which we do not use the long division method, but we can easily say whether the remainder becomes 0 or whether the divisor is completely divides the dividend. Let's find out those procedure. Okay, let's do with this examples. Here the dividend will be how much? Here the dividend is x cube plus x square plus x, and here the divisor is x. We do not do here the long division method. Okay, how we can define whether the remainder becomes 0? See, in the dividend side there are how many terms? There are 3 terms: x cube, x square and x. In all these 3 terms, here the variable is x, here also the variable x, here also the variable x. That means it contains x, it also contains x, it also contains x. Understood? Since it has 3 terms and each term also contains x, that means x is the common factor. Okay, understood? So the first category we can easily define that x is the common factor. And as we know, if x is a common factor, that it completely divides the dividend, and if it completely divides dividend, the remainder becomes 0 here. So since there are 3x, it also contains x, it also contains x, it also contains x, that means x is the common factor, and that common factor completely divides the dividend, so that the remainder becomes 0. Here we do not need long division method. Okay, let us do it one more example so that you can easily understand. Suppose the question is like this: divide this by x. Here dividend is x cube plus x square plus 1. Clear? And divisor is x. Now we have to determine whether x is a factor of this or not without doing long division method. Okay, see, in the dividend side we have 3 terms: x cube, x square and 1. Okay, so in these 3 cases, x cube contains x, yes, x square also contains x. Clear? But does 1 contain x? No, because 1 is a non-zero constant polynomial. It does not contain x. Okay, it does not contain x. So since it doesn't contain x, so can we get out the common term x as a factor? X could a common factor bhaya pai pariba ki? No, because the 3 terms doesn't contain x. Okay, though the 2 terms contain x, but it doesn't contain x. That's why x is not the common factor, not common factor. So we can easily prove whether a number or a polynomial is a common factor of this or not. Since x is not a common factor, so by dividing x cube plus x square plus 1 with x, do you get 0 as a remainder? No, you cannot get 0 as a remainder, because the x is not a factor of x cube plus x square plus 1. Clear? So let us do it one more example. Suppose we have x cube plus x square plus 2x, okay, by x. Clear? So without dividing or without using long division method, we have to verify whether x is a common factor of this or not. Now here the dividend is x cube plus x square plus 2x. It contains how many terms? It contains 3 terms: x cube, x square and 2x. Clear? Now here x cube contains x, okay, x square also contains x, because x into exact square. Similarly 2x also contains x. Clear? So in this, all these 3 terms contain x, so we can say that x is a common factor of x cube plus x square plus 2x. Since x is a common factor, so it completely divides this term, so the remainder becomes 0. So clear now? By using the long division method or without using a long division method, we can say whether a number or a polynomial is completely divides the other polynomial and whether the remainder becomes 0. Let us do with another long division method. Or divide x cube plus 2x square plus x by x plus 1. Okay, we have to divide x cube plus 2x square plus x by x plus 1. Okay, so here in this case the dividend is how much? This one is the dividend, so we can write here, dividend is how much? Dividend is x cube plus 2x square plus x. Okay, and divisor is x plus 1. You can say divisor is equal to x plus 1. Now let's divide. We have to get x cube, so we have to multiply x square here. X into x square is x cube. Clear? Then 1 into x square is x square. Now these two cancelled out. 2x square minus x square will be x square plus x. Now multiply one another x with x, so that it will be x square plus 1 plus x will be 1 into x. So after subtracting, this two also cancelled out, this two also cancelled out, hence the remainder becomes 0. Here also get that remainder becomes 0. Since the remainder becomes 0, so we can say that x plus 1 completely divides x cube plus 2x square plus x, and it is a common factor of x cube plus 2x square plus x. Clear? Here dividend is this, divisor is x plus 1, and this term is known as quotient. So we can write quotient is how much? X square plus x. Clear? Okay. Then here the remainder is how much? 0. Clear? So this is dividend, divisor, quotient and remainder. See one thing. Dividend is a polynomial or not? It is a polynomial of degree 3 because highest power is 3. So we can say for polynomial, we can say dividend is written as p of x. Okay, it is written as p of x. Since it is expressed in terms of x, we can write dividend as p of x. So here p of x is how much? X cube plus 2x square plus x. Then divisor comes to divisor. Here divisor is also a polynomial. Okay, it contains two terms, so it is a binomial. So divisor be gote kona polynomial. Okay, we can say divisor also a polynomial. That's why we can say it as g of x. G of x means g means also polynomial. P means polynomial, G means also polynomial. So G is also a polynomial in terms of x, and G is written for divisor. So we can say G of x is x plus 1. Clear? Now comes to quotient. Okay, see, quotient is also a polynomial of two terms. So it is also a binomial. So we can write quotient as q of x. Q means also polynomial. So is equal to how much? X square plus x. Okay, then remainder. Remainder is how much? 0. 0 is also a polynomial and it is known as zero polynomial. So we can write remainder as r of x. In some cases the remainder becomes 0. In some cases remainder might be 1, 2, 3. Okay, any constant term. So for that we can write the remainder as r of x is how much? 0. So clear? So for polynomial you have to keep in mind that the dividend is always written as p of x, the divisor always written as g of x, the quotient written as q of x, and the remainder written as r of x. Okay. Now we will determine the degree of such polynomial. Okay. Since p of x is also known as dividend, so here p of x is a polynomial and its highest power is 3. Hence its degree will be written as 3. Clear? Then coming to g of x or divisor. For this case here this polynomial has the highest power 1 and it has the power 0. So the highest power is 1. So that we can write its degree as 1. For quotient or q of x, here the highest power is 2. Hence we can write the degree is 2. But r of x is 0. 0 is a 0 polynomial. As we know, we cannot determine the degree of 0 polynomial. So we can write it as undefined. Okay. So this is one case. Let us define another case. Suppose we have to divide 7x plus 2. Okay. 7x plus 2 by x plus 1. Clear? Okay. So here p of x is how much? P of x means dividend 7x plus 2. Clear? X plus 1 is divisor. So you can write it as g of x. X plus 1. So now let us divide. We need 7x here, so we have to multiply 7. So that x into 7 is 7x. 1 into 7 is 7. So after subtraction, these two are cancelled out. 2 minus 7 it is equal to minus 5. This is the remainder. Okay, this is remainder, and this is quotient. Here. Now let's write here. Here q of x is equal to, q of x means quotient is how much? 7. Clear? And remainder will be r of x. Here remainder is minus 5. Okay. Then now write the degree of such polynomial. Okay, degree. In the first case, for the dividend, here the highest power is 1, and the degree of dividend is 1. In the divisor case, it is also the highest power 1. So here also the degree is 1. Q of x means quotient. Quotient is 7. 7 means it is a non-zero constant polynomial. Since it is a non-zero constant polynomial, that means we can say its degree is 0. We have also know that for non-zero constant polynomial the degree is 0. Here remainder is minus 5. Minus 5 is also a non-zero constant polynomial. So for this case the degree will be how much? 0. Clear? Now let us compare these two cases. You see, in the first case this is the dividend and the degree of dividend is 3. Okay, and the degree of the divisor is 1 and the degree of the quotient is 2 and degree of the remainder is 0. That means undefined. Okay, so undefined means it doesn't have any value. So finally we see that 3 is greater than 1, 3 is also greater than 2. So the conclusion is that the degree of the dividend is always greater than the degree of divisor. तामाने dividend रो degree सबुबेले काटु बड़ा हबो, divisor रो degree ठारो बड़ा हबो. So we can write it as degree of dividend. Okay, degree of dividend is greater than which one? Degree of divisor. Degree of divisor. Okay, clear? But in the second case, you see, here the degree of the dividend is 1, but here also the degree of the divisor is 1. That means the degree of dividend is equal to the degree of divisor. So we can say the degree of dividend in the first case we get is greater than degree of divisor, but here we say we get degree of dividend is equal to degree of divisor. So we can write the degree of dividend is always greater than or equal to degree of divisor. तामाने एटार डिविडेंड रा डिग्री सब बेले डिवाइजर डिग्री ठारो अधिका हबो or equal habo, but cannot be less than the degree of the divisor. So this is clear. Then comes to the next term. Here we see the degree of the dividend. Here also the degree of dividend is always greater than the degree of the quotient. 3 is greater than 2. Okay. Here also 1 is greater than 0. Okay. So the degree of the dividend always greater than the degree of the quotient. You can say this is the one. Second the degree of dividend is greater than degree of quotient. Understood? So now comes to the third point. Okay. So here you see the degree of the remainder in this case, in the first case, is undefined. That means it has no value. And the degree of the divisor is 1. That means 1 is greater than undefined. Clear? In the second case, the degree of the remainder is 0. Okay? And the degree of the divisor is 1. That means 1 is greater than 0. Or the degree of the divisor is greater than degree of the remainder. Okay? So we can say that the degree of divisor, okay, the degree of divisor is always greater than degree of remainder, is greater than degree of remainder. This is the third point. Next is the fourth point. Here also see, here the degree of the quotient is 2 and the degree of the remainder is undefined. That means 2 is greater than undefined. So the degree of the quotient is greater than degree of remainder. But here in this case, the degree of quotient is 0. Here also the degree of remainder is 0. That means the degree of the quotient is equal to degree of remainder. But here we get the degree of the quotient is greater than degree of remainder. Here we get the degree of quotient is equal to degree of remainder. So combinedly you can say the degree of quotient is greater than or equal to. Okay, here we get greater than, here we get equal to. Degree of remainder. You should write down these 4 points. It is necessary because before performing any long division method, you have to follow these 4 steps in your mind. Okay. So from these 2 cases, we can compare and get a final conclusion. Okay. So finally, you get that the degree of the dividend is always greater than or equal to the degree of the divisor. Okay. And the degree of divisor is always greater than degree of remainder. The degree of the quotient is greater than or equal to degree of the remainder, and finally the degree of the dividend is always greater than or equal to the degree of quotient. These are the 4 basic notes or basic fundamental condition for a long division method. Now we will discuss about another concept of long division method. So for this we have to take an example. Suppose we have an example, divide x cube plus 7, okay, by x square plus 1. We have to divide x cube plus 7 by x square plus 1. Okay, let us divide. We need x cube here, so that we will multiply x. So x square into x cube and plus 1 into x. So after subtraction, these two will be cancelled out. So we have minus x plus 7. You see here the degree of the divisor is 2 and the degree of the remainder is 1 and the degree of the quotient is 1. As we know, the degree of the remainder cannot be greater than the degree of the quotient and cannot be greater than the degree of the divisor. So that we will not perform the long division method further. Stop the long division method here. Okay. So now we will write what will be the dividend, divisor, quotient and remainder. So in this case, we have the dividend is x cube plus 7, okay, and this is the divisor. So g of x is equal to how much? X square plus 1. Now this is the quotient. So q of x is how much? X, okay, x, and this is the remainder. R of x is equal to minus x plus 7. So now we have to compare all these 3 cases. This is the first case, second case and third case. Now discussing about the first case. You see in the first case, this is the divisor. G of x is known as divisor and the divisor is x plus 1 and it is a binomial term and the highest power is 1. Since the highest power is 1, it is known as a linear polynomial. Why? Because if the highest power is 1, then it has the degree 1. Since the degree is 1, so it is known as linear polynomial. Okay, clear? Then comes to the second case. In the second case, here also the divisor is x plus 1 and its hash power is 1. That means it has the degree 1. Since the degree is 1, so you can write it as linear polynomial. So it is also a linear polynomial. Okay, then comes to the third case. In the third case, the divisor is x square plus 1. Here the hash power is 2. That means degree is 2. So it cannot be written as linear polynomial. It is told as quadratic polynomial because if the degree is 2, then it is known as quadratic polynomial. Okay, so we find that this is a linear polynomial. For this case, the divisor is linear. For the second case, the divisor is linear. But for the third case, the divisor is not linear, it is quadratic. So here you see, if the divisor is linear, the remainder will be 0. 0 is a constant or not? Yes, it is a constant. Though it is a 0 polynomial, but it is a constant. It is a 0 polynomial. And here also, if the divisor is linear or linear polynomial, then the remainder is minus 5. Minus 5 is a constant or not? Yes, minus 5 is a constant polynomial. It is a non-zero constant polynomial. But if the divisor is not linear or it is a quadratic, degree more than 1, then what will happen? You see, the remainder is not a constant. It is a polynomial of degree 1. Okay, it is not constant. Not constant polynomial. Okay, again we see here, if the degree of the divisor is linear, that means if the divisor is linear, then the remainder is 0. 0 is a constant. Here also, if the divisor is linear, then the remainder is minus 5, which is also a constant. But if the degree of the divisor is not linear or it is quadratic more than degree 1, then the remainder is not a constant polynomial. It may be a polynomial greater than whose degree is greater than 0. Okay, so we are clear. So you can say note 2. What is the note 2? If the degree or if the divisor is a linear polynomial, okay, then the remainder will be how much? The remainder is always remains constant. Then the remainder is a constant. Write it down. Clear? So if suppose we have another case. If the divisor g of x is x cube plus 1, then will be the remainder becomes a constant? No, the remainder will not be a constant. Why? Because the degree of the divisor is 3. It is not linear, it is cubic polynomial. Okay, if the divisor degree is 1, here see, it is a linear polynomial. So we can say that the degree of the remainder is always constant or the remainder is always constant. Okay, this is all about today's classes. Thank you.